So this is an alternative solution to this question. So if you have this, and then you don't want to expand this, you can just use what is known as the use substitution method. You can just let your u be 3 minus 4x, and then your du dx will be negative 4, which you can cross multiply and have du is equal to negative 4 dx. So remember that you want to substitute everything that has an x with everything that has a u. So I'll substitute this entire thing with a u, and then I'll substitute this with whatever I'll get from there. So I can just change the subject of the formula here to dx. My dx will be du over negative 4, like this, and then I can substitute this dx in there, and I can substitute this with this, and then integrate. Of course, you can also change the limits by substituting these numbers in there to find the new u and the new the new lower limit and the new upper limit. So to find the new lower limit, okay, let me just write this. So we have the integral. I'm not going to include the limits. So instead of writing this, I can just use my u and say u. And then instead of writing dx, I can write this du over negative 4. And then for the limits, my lower limit here is a 1, but this is an x. So to find the corresponding u value, I can just say u is equal to 3 minus 4, and then where there is x, I can put negative 1. So that means we have this, and then this will be a 4. So our u will be a 7. So this one will be a 7. That will be our lower limit. As you may have guessed, the upper limit will be 3 minus 4. Instead of having an x, I'll put that to there. This may not be your favorite method, but I just thought I should give it to you anyway. So you have this, and then you can integrate. Whatever you get is the same as what someone who expands this will get. So I can just factor the 1 over negative 4 out, so that I can make it easier for myself. Of course, this is raised to the power 3, so you have to put a 3. And then when you integrate this, you have u to the power 4 over 4, and then you are integrating from 7 to negative 5. So you have negative 1 over 4, and then I can substitute my 5 in there. So you can say negative 5 raised to the power 4 minus, of course, everything is over 4. Maybe we should take this one outside since it's a constant. So this one will be 1. When you put it outside, it will multiply by this, so that you have this. And then in the brackets, we just remain with this, which will be much easier to work with. And then you can just substitute this. You have negative 5 to the power 4 minus this one here, 7 to the power 4. And then using my calculator, I know that this will be a positive number, so So 5 to the power 4 is 625. Then 7 to the power 4 is 2401. Then we can subtract these two numbers, 625. So I'm getting negative 1776. Then divide it by 16. We have 111. So this is an alternative way of solving. For part B, the diagram shows part of the curve y is equal to cos theta rather. So this should be the theta axis. And intersecting y is equal to sine theta at P. Find the coordinates of P. So to find the coordinates of P, I'll use a different method where you are not required to rely so much on your calculator. So to do that, we can just solve y is equal to cos theta and y is equal to sine theta simultaneously. So I can just substitute this one in here and say sine theta is equal to cos theta. But as you can see, these two are unlike terms. So even if I take this to the other side, there is nothing I can do. But we know that tan theta is equal to sine theta over cos theta. So I can just take advantage of this fact and divide both sides by cos so that I obtain a tan, which is much easier to work with. So dividing both sides by cos, we have a 1 this side, which is good. Then we have a tan this side, like this. And then from this triangle, this one here, where I have 1, 1, and then the square root of 1, and then this is 40 degrees. But because we are using radians, 40 degrees is this over that. So from here you can see, actually this is 45. From here you can see that the angle under discussion here is theta is equal to pi over 4. So if you decide to use your calculator using degrees, you can find 45 degrees by taking the inverse tan of this, and then you can convert it to radians, or you can just use your calculator in radians and find an approximate value of this. So now remember that we are trying to find the coordinates of P. So you have to find the y coordinates as well. So using the same triangle, you can pick any of the two equations. I'll pick this one because our theta is pi over 4. So when I use this triangle, I can see that cos theta here, which is like 45, is 1 over the square root of 2. So this is 1 over the square root of 2. So the coordinates for P are pi over 4, 1 over the square root of 2. With this, you don't need too much of calculator work. So now find the area of the shaded region. To find the area of the shaded region, you can just say area is equal to, you find area 1, which is the area of the integral of cos theta. So you're integrating from 0 to this point here, which is pi over 4. You don't need the y coordinates, you just need the x coordinates. So you're integrating from here to there. Then the first function is this one here, cos. So you can put your cos theta, and because we have the same limits even for the other function, you can combine them and say cos theta minus the smaller area here, which will give us this area. So once we subtract this from this entire thing, we shall remain with the area of the shaded region. So we have this, and then the theta, like that. And then we know that the integral of cos is sine, which is a positive. So we have sine theta, and then the integral of sine is negative cos theta. And then you are integrating from 0 to that pi over 4. So in short, in the brackets, in the square brackets, we have sine theta plus cos theta 0 pi over 4. And then you can simply substitute these values in here and solve. So when I substitute the sine, the theta, the theta in the sine, then I have this. And then here I'll have this. Then everything minus this. Remember, it's f of pi over 4, this one, minus f of 0, which is this, where f is this thing here. Then for 0, you have sine 0 plus cos 0, like this. This, using the triangle again, 1, 1, forgive my drawings, where this is 45. So using this triangle, you can see that sine pi over 4 is opposite over this, which is 1 over the square root of 2, plus this is still the same thing because cos this is 1 over the square root of 2. Then everything minus this is a 0, and then this is a 1. So now we can add these two. Then you have 2 over root 2 minus 1. So you can either leave it like this or rationalize this. So to rationalize, I know this may not be familiar to most of you, but this is what it means. You just multiply by this to get rid of, to rationalize is to get rid of the radicals on the denominator. So this times this and this times this times this will give us 2 root 2. Then this times this will give us a 2. Remember, this is the same as 2 times 2, which is 4, and then the square root of 4 is 2. Then you can cancel these 2 out, so that you have the square root of 2 minus 1 as your final answer. So this is the second method. When you punch this on your calculator, you realize that the answers will be the same as what you get when you use your calculator.